Hello everyone. Today I'll discuss the chapter number 6, which is spectrum. But before starting the spectrum chapter, I want to discuss about the light. Means what is wavelength of light, what is the frequency of light. So let's start from the light. See, what is light? Light is a electromagnetic wave. Now you remember, light is a wave. So it looks like this. Okay? And if we draw one line, so this is the wave, diagram of the wave. Now look, from sun we get the white light, and all of we know, you have studied the prism chapter, and there we have read when a white light passes through a prism, it splits or it disperses the white light into 7 colors. Means white light is a mixture of 7 colors. We know about the 7 colors of light, which is Vibgyor, V-I-B-G-Y-O-R, violet, indigo, blue, green, yellow, orange and red. Now if I ask the question, what is the difference between red and violet, or out of them any 2 colors? How would you differentiate them? To differentiate between 2 colors, one term you have to learn, what is which is called the wavelength of light. Means wavelength. Okay, this wavelength is represented by the lambda. This is called the lambda. Now I am explaining by the diagram. Before that, what I told, light is a wave. So I am taking 2 light, which is red and another is the violet. So for red color, I am drawing the diagram for red. Suppose this is the wave for red color, and look, in this red color, what is wavelength? The distance between 2 peaks is called the wavelength. Otherwise, for one complete wave means from here to here. This is the one complete wave. So this distance also, it is called the wavelength. It is represented by lambda. Now if we draw the wave for a violet, how it looks like? This is like this. Means what is the difference? Look, here the difference means the distance between 2 peaks is large, but here the distance between 2 peaks is very small. And if we take this one, means one complete wave, so this is the common complete wave. This is also called the lambda. Now one thing we can say from here, the wavelength of red light, it is more than the wavelength of the violet light. Now if you look at the graph, what is the another difference? See, in this position, in this region, if we count the number of waves, here 1 and half, and here 1, 2, 3, 4, 5, 5 and half. Means I want to say the number of waves for red, it is less than the number of waves in case of violet. So that number is represented by one term, which is called the frequency. Okay. So what is the conclusion we can draw from here? Means the light which has more wavelength, that has less frequency, and the light which has less wavelength, that has more frequency. Okay. If we see the action of the prism, we have seen when a light passes through the prism, then the diagram is like this. And here if we draw the normal, then this angle is the delta 1, which is represented the angle of deviation at the first surface, and if we draw the normal at the second surface, then this is the angle of deviation at the second surface, which is delta 2. Means which one is delta 2? This is delta 2. That's why it is vertically opposite. So here this angle I have written here delta 2. And what is delta? Means angle of deviation delta, this one. So now if you see this triangle, this is the exterior angle, and exterior angle equals to sum of 2 interior angle. So here we can write delta equals to delta 1 plus delta 2. This angle of deviation depends on 3 factors. First one is the angle of incidence. Angle of incidence, which is represented by I. Now how the angle of deviation depends on angle of incidence? See one graph we have seen. This is suppose delta, angle of deviation versus angle of incidence. We have seen the graph comes like this, means when the angle of incidence first increases, then angle of deviation decreases, okay, and after a certain value, again with increase in angle of incidence, the angle of deviation increases also. Means that point where it is minimum, means that delta is giving the minimum value, that is called the delta mean, means angle of minimum deviation, and at that point angle of incidence equals to the angle of emergence. Means what is the definition of angle of minimum deviation? The point where angle of incidence equals to the angle of emergence. And the second factor is the angle of prism. This is represented by A, because one relation we have seen, delta mean equals to twice I minus A. Okay, so angle of deviation depends on the angle of prisms also. So what is the third factor? This third factor is the mu, means refractive index. So refractive index of the material. Now we have learned that refractive index depends on the lambda. How it depends? The refractive index is inversely proportional to lambda, means which has more wavelength, that has less refractive index. So we can say the violet lambda V, it is less than lambda R. Okay, lambda R means wavelength for red. So the mu for R will be less than, here I am writing mu for V is greater than mu R, means refractive index of violet is more than the refractive index of red. Now the relation is the angle of deviation decreases with increase in wavelength, means for the red color the angle of deviation is less, means angle of deviation delta for red, which is less than the delta for violet. Otherwise one relation we know, delta equals to mu minus 1 into A. So from here we can say the angle of deviation is less for the red, because mu R is less than mu V. Okay, otherwise delta V it is greater than the delta R, because why? Look, mu R it is less than mu V. So mu and delta directly proportional. So obviously we can say that delta R is less than delta V. Okay, clear? In case of prism, when the white light passes through a prism, then that prism splits into the 7 constituent color. So the diagram looks like this, means if we keep a screen, then this will be red and this will be violet. So my question is, why does it happen? Means why the red color bends least and why the violet color bends more? Look, the answer is, when the light is traveling in a air, then the speed was 3 into 10 to the power 8. Now when it is entering in a medium, then the speed will remain same or it changes. Obviously the speed changes when it is entering in a medium. So due to change in speed, that white light separates into its constituent color. Now what was the third factor? The third factor was the deviation decreases with increase in wavelength, means that which has more wavelength, that for that case the deviation will be less. So we know the lambda for red is greater than lambda for violet, means the red color has more wavelength than the violet color. So the bending, means delta for V will be more than delta for R. Okay, that's why this violet color bends more and the red color bends least. Now from sun, actually we see the white light is coming, means the light which is visible for the human eye, that we see, and that is the white light, means we know that is VIBGYOR. That is VIBGYOR, and the mixture of that colors is white light. Now look, the question is, what is the wavelength of the red color and what is the wavelength of the violet color? So the range is 4000 Armstrong to 8000 Armstrong. Means for violet, this is for violet, the wavelength of the violet light is 4000 and the wavelength for the red is 8000 Armstrongs. Okay, in nanometer if you write, then 400 nanometer to 800 nanometer. So this is the range of the wavelength of the visible light. So how to convert the Armstrong to nanometer? Means divide by 10. Okay, so 4000 divided by 10 means 400 and 8000 divided by 10 is the 800. Now what is the definition of refractive index? The refractive index is the speed of light, suppose V in air, divided by speed of light in glass. Suppose this is glass. Now we know the speed in case of white light, when it splits, the speed of light for red color, means speed of the red color it is more and speed of the violet color it is less. So means for medium, so we can say for mu for violet it is more than mu for red. By the wavelength also we can find out the relation also, because lambda r it is greater than lambda v. So from here we can find out the mu v greater than mu r also. Now see, one relation we know, mu equals to sine I divided by sine r. So from here we can write sine r equals to sine I divided by mu. Okay. See, from this equation, as mu r is less than mu v, so from here, as this angle of refraction is inversely proportional to the refractive index, so mu r will be greater than, I am telling this the angle of refraction. So the angle of refraction for red color it is greater than angle of refraction for the violet color. Okay, because they are inversely proportional. So from the equation delta equals to I minus r, we can write that delta v it is greater than delta r. So from here also we can find out the angle of deviation for violet, it is greater than the angle of deviation for the red color. See here, delta equals to I minus r. So as this r means the angle of refraction for the red color is more than the violet color, that's why obviously it will come delta v greater than delta r. Okay. Next heading is the Newton's experiment. What was the experiment? The experiment is when a sunlight or when the white light passes through the prism, it splits into 7 constituent colors. So that experiment was done by the Newtons, and he did that experiment in dark room, and the experiment is when the sunlight is allowed to fall on the surface of the prism, then he saw, and he kept one screen behind the prism, then he saw that white light splits into 7 constituent colors. Okay, and that band of 7 colors, this is red, this is violet, and that band of 7 colors means VIBGYOR, VIBGYOR. So that band of 7 colors is called the spectrum. Okay, this is spectrum, means when the white light passes through the prism, it splits into 7 constituent color. That band of 7 colors is called the spectrum. Okay. What was the conclusion of that experiment? The conclusion is the white light is the mixture of 7 colors. Means the white light, we can say this is the polychromatic light. So what is the meaning of polychromatic? Polychromatic means, poly means more means which has more wavelength, which is the mixture of the colors. Polychromatic. And what is the meaning of monochromatic? Monochromatic means single wavelength. Monochromatic, mono means single. Okay, poly means more. When it contains more number of wavelength, that is polychromatic light. So white light is a polychromatic light, and monochromatic light, single light, red, violet, only violet, that is monochromatic light. Okay. Now what is the definition of dispersion? The definition you will write: when the white light passes through the prism, it splits into 7 constituent colors. That phenomenon is called the dispersion of light. And what is spectrum? See, on passing the white light through the prism, a 7 color is obtained. That band of 7 color is called the spectrum. So next topic is why the dispersion occurs. Look, when a white light passes through the prism, it splits into 7 constituent colors. Now, when the white light travels in the air, then the speed we know, which is 3 into 10 to the power 8 meter per second. But that speed is in air. This is white light. But when it enters in a medium, see, white light contains 7 constituent colors. Means all the light are traveling with this speed, with the speed of 3 into 10 to the power 8 meter per second. But when it is entering in a medium, then speed of the light, means for violet or for red, for green, for all the colors, speed is different. Okay, so when the speed changes, so due to the change in speed, they deviates with the different angle. That's why we got the 7 constituent color if we place one screen over here. So this will be red and it is a violet. Okay. Now one important question comes: in which surface the dispersion occurs? See, here the surface where the incident rays are falling, on that surface the refraction occurs. And on the second surface, when it is falling on the second surface, then here only the refraction occurs. Refraction means when the light goes from denser to rarer. This is glass, this is air. So this is denser medium and this one is the rarer medium. So when the light passes from denser to rarer, then it bends away from the normal. See, if we draw the normal over here, it is bending away from the normal, and here also it is bending away from the normal. Okay, so on the first surface the dispersion occurs. And one more question comes: the deviation also occurs at one surface or on the two surfaces? No, the deviation occurs at both the surfaces. And another conclusion we can draw from here: the prism does not produce light, only it separates the light, it splits the light. Okay, prism does not produce light, only it separates the light. So this is all about the dispersion and deviation. In next class I will start the electromagnetic spectrum. Okay. Thank you.